put them together and it's gonna form this particular shape. Okay, so where is this shadow? Right here?
On the right hand side.
What letter do you want to use to represent this? It's called the X. Cool? Alright, so what are we trying to find? How fast is the shadow lengthening when he is 10 feet from the pole? So we're looking for what? ds dt. When?
X is 10.
X equals 3. Is that correct? 10? Did you say 3 or 10? Oh, you said 10. Sorry, I heard 3. Just write what you say. And then we'll talk about it if it's right or wrong, right? So x equals 10. Given? dx dt equals 5 feet per minute. Okay? It doesn't move at all? Really slow? It moves 5 feet every minute, right? So he's like,
Dun 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 dun.
Like, that was like 15 seconds.
15 seconds?
He was slower than that.
Oh, I'm sorry.
Yeah, do it.
Maybe
Maybe
you
I
like
like start walking this way.
Maybe
Okay,
I like
stop.
Alright, anyway. These are just theoretical problems, right? When are you ever gonna need 300 watermelons, right?
What? I want watermelon.
Okay, so how can we set up the equation for this one? Because we don't know which one to use, we gotta set one up. Do you see the proportions already?
Mm-hmm.
Alright, so draw your two triangles, just to help you, so you don't mess up. This one's 24, and how much would the bottom be for the big triangle? X plus S. And the little one will measure what? 6 and S. Now let's set up our proportion to be able to get our equation that we can differentiate. How do you want to set it up this time? Same way? Okay, so tell me what to write. 24 over X plus S, okay, equals? Over S, okay. Cross multiply. We've got 24S is equal to 6x plus 6s minus the 6s, right? And we get what? 18s is equal to 6x. What are we ultimately trying to find? ds dt, so maybe we should make it s equals? If we're looking for a dx dt, then it would have been better to make it what? X equals, right? So I know that s is equal to 1 over 3x. Alright, let's do it. What's its derivative? ds dt equals 1/3 dx dt. So that's going to end up being 1/3 times what? 5, which is going to be 5 over 3, and what are the units? Feet per minute. That's the rate of change of the shadow, right?
Is it like a 6-foot turtle?
Cool? Alright, let's look at part B. How is that one different? How fast is the what?
Tip.
End of his shadow moving when he is 10 feet from the pole. And now they're talking about the end of the shadow. Is that the same thing as the tip?
Yeah.
Yes. What letter do you want to use to represent that?
T.
E? E for end of what?
Shadow.
Shadow. So what's going to be my find? DE dt. So that's
Thank you.
when x equals 10 feet, given dx dt equals 5 feet per minute. Okay? What's the equation we're going to use here for the end of the shadow? How do we find out where the end of the shadow is? X plus s. Beautiful. Right? If I add this distance plus that distance, it gets me here. Alright. So differentiate. So dE over dt is equal to dx over dt plus ds over dt. And do we know those two rates of change? Yes, what are they? 5 and 5/3. So divide by 1, so that's times 3, so that's what? 15 plus 5? 20 over 3. What units? Feet per minute. Kindergarten stuff?
Sure.
Sure? We okay with shadow problems? You got it? So that's how they ask shadow problems. They either ask how the length of the shadow is changing or how the tip of the shadow is changing. They won't ask you anything else. Okay? They might ask at what rate is the person walking, but if they ask that, then they give you the rate at which the shadow is changing. Okay? They'll set it up for you so that way you know one or the other to solve for you. Cool? Alright, let's move on. So the next set of problems are going to be the what?
Cone.
The cone problems, alright? The first two cone problems are going to be problems where they kind of give you almost everything that you need to be able to work it out. And then the last two are problems where they don't give you that extra part that they gave you on these two. You need to find it first. Again, by using similar figures. Okay? Yeah? Are we alright? Yeah, we're hanging in there?
Yes.
Okay, we're almost done, okay? I can do one example of this one and one example of the other one and that's it, not do two of each if you want.
Yes.
You want me to do that?
Do two of each.
Some of you are smart enough to like not need both of them.
Do two of each.
We're gonna run out of time?
Let's do one today.
And then the other one tomorrow.
I mean, for sure, we'll be able to do 3. Like, I'll be able to do these 2 and one more.
Yes.
Just to refresh.
Yeah.
How about we do 3 and then tomorrow I do 1, just to refresh.
You're right.
Nah, that's good.
But at least that way you'll be able to do them on your homework, right?
No.
Anyways, let's stop talking about it and get it done, right? So let's see here. At the instant when the radius of a cone is 3 inches, the volume of the cone is increasing at a rate of 9 pi cubic inches per minute. If the height is always 3 times the radius, find the rate of change of the radius at that instant. Okay, so what are we trying to find? dr dt. Rate of change of the radius. And what shape are we talking about? A cone. So we got a cone. That cone has a radius and it also has a what? Height. What did they tell us about the height? It's always 3 times the what? Radius. They already told us that, right? Okay, so when do we want dr dt? They said they wanted it at that instant. What is that instant? At the instant when the radius is what? 3, right? So r has to equal 3 inches. So far so good? Given, what are they giving us? The volume of the cone is increasing at a rate of 9 pi cubic inches per minute. So they're giving us dV dt, and they're telling us that it's 9 pi inches cubed per minute. Are we okay? And they also told us that h also always equaled what? 3r. Are we good? Okay, so what equation do you think we're going to have to use in order to find dr dt? The volume? Volume of a what? Cone. So let's write that formula down. What is it? 1/3 pi r squared h. Some of you on your homework, you're just looking at your handout, right? Okay, you need to try and know the formulas and also know how to differentiate them without looking at the handout. Okay, because you're not going to have that on the day of the test. Okay, so let's look at it. So I know that when I get the derivative of this guy, I'm going to end up with a dr dt, and I'm also going to end up with a dh dt. Okay, but what is it that I have? I have r and I have dv dt. Do I know anything about h? I know that it's 3r, right? But do I know anything about dh dt?
It's 0.
No. Could I find dh dt using this? Yes. But do I want to have the equation with two variables? I'd rather have it with one variable, right? What could I do with this h?
Plug in a 3r.
I can replace it with 3r, so everything's in terms of r, and then that'll make my life easier when I get the derivative, because I don't have to do product rule. I don't have to get the derivative of that and then plug it in, right? We understand? Okay? So on these problems, that's the tricky part. You have to think about, what do I have to change in the equation to make it work for me? All right, so here what we want to do is we want to what? Replace h, right? With what? With 3r to have the equation in terms of r only. Because that's what I want to find, r, and that's what I'm given, so I want to work with that. Okay, and that's where the other two problems are a little bit different. On the last two, they don't tell you this relationship. They don't tell you how h and r are related. You have to figure that out yourself and then plug it in like we're doing here. So these are kind of like baby stepping with you. Right? This problem tells you how they're related, so you use it automatically. The next one doesn't tell you. You got to figure that out first and then plug it. That's the only difference. So let's rewrite the equation. Volume equals 1/3 pi r squared times what? 3r. Okay. What happens with this 3 and this 3?
Cancel out.
Okay, what's r times r squared? R cubed, right?
Yeah, sorry.
Okay. So now can I differentiate it and end up with things that I have or that I want? Yeah. So this gives me dv dt equals what? 3 pi r squared dr dt. Do I know dv dt? 9 pi, plug it in. Times 3 pi equals 3 pi. What's r? 3 squared dr dt. You see how that worked out for me, made it a whole lot easier? By replacing that h. So I always have to look at and see what it is that I'm looking for to make sure that my equation is in terms of that level. Make my life easy. Alright, so 3 squared is 9. 9 times 3 is what? 27. So all we have to do is divide by 27 pi, right? The pi's are gone, and what's 9 over 27? What? 1 over 3. What units? Inches cubed?
Oh wait, no.
Just inches per minute?
Yeah.
Why not inches cubed?
You're not finding it.
We're not finding volume, right? It's just the radius, the length of the radius. And what is that radius?
I saw the beam and I was like, cute. I was like, wait, so.
Are we okay? Another one? you wanna jump to the other example where they don't give you something like this?
Another one.
Another one, the same kind? Okay. So let's look at number 4. At a sand and gravel plant, sand is falling off of a belt, so they have a conveyor belt and it has sand on it. And the conveyor belt is turning, and as it turns and it goes around, the sand is falling, right? So as that sand falls, it's forming a pile in the shape of a what? Of a cone, a conical pile, at a rate of 10 cubic feet per minute. Okay, the diameter of the base of the cone is 3 times the altitude. At what rate is the height of the pile changing when it is 15 feet high? Okay, so the conveyor belt is dropping the sand and it's forming a cone, and the cone should look like this, not the other way around, right? And they told us that this is the height, right? And then this is the diameter, right? So what did they tell us about the diameter? 3 times the altitude. What's the altitude? The height, right? The distance from the base to the highest point on the shape. Okay, so 3h. So if the diameter is 3h, what's the radius?